Understanding why motion happens is best done through an understanding of Newton's laws of motion. Newton's first law of motion says that if there is no net outside force, the object will not change its state of motion. Net implies total force. Outside means the force must be applied by an object other than the object that's moving. So a force from outside, and net means total. So if there's no total force from some kind of outside object, the object will not change its state of motion. So if the object started at rest, it will stay at rest. If the object was moving, it will continue to move at the same speed and in the same direction. Newton's second law says that acceleration increases with increasing forces. The harder you push on something, the quicker it's going to accelerate. And acceleration decreases with increasing masses. More massive objects will not accelerate as rapidly as lighter ones. Newton's third law says that it takes two objects to make a force. Each object will experience the force in equal magnitude, but in different directions. It's this law that I want to spend some time illustrating because I think it's the hardest one to grasp. Okay, so take for instance the idea of the moon and the earth. We already know that there is a force gravity acting between these two objects. Okay, so let me pull up Omnidazzle, and we will take a look like we did before with the pen. So Newton's third law says that the earth pulls on the moon, and the moon pulls back on the earth with a force that is equal to, but in the opposite direction. So each object experiences the same force, but they do so in opposite directions. Okay, if we look at this helicopter again, and we focus on either of the two ropes, we will see that the rope is pulling up on the basket, and that the basket is pulling down on the rope. We could see that the helicopter is pulling up on the rope, and that the rope is pulling down on the helicopter. We could see the rope is pulling the person forward as the person pulls the rope the other way. We could see that the basket is being pulled by the rope, but the rope is also being pulled by the basket. So at all points, we have forces that are equal and opposite. Okay, for this thing with the object on a spring, we have the spring pulling up on the mass, and we have the mass pulling down on the spring. Again, we could have equal forces up at the top here. So the spring is pulling down on the support, and the support is pulling up on the spring. Again, Newton's law, equal and opposite forces. With this block, we have the block pushing down on the table, and we got the table pushing up on the block. Okay, with this one, we can see the person pushing the toy train to the right. The toy train will be applying an equal but opposite force on the person to the left. So this is Newton's third law. It says it takes two objects to make a force, and each object will experience a force equal in magnitude but different in direction.